So as we were discussing, so now we have to think of a way where we can use the text as it is and classify things, right? So as of now, we just discussed what are the different ways of pre-processing the data. We discussed about ways to kind of what are the different applications, information retrieval and supervised, unsupervised ways of doing NLP. So now the last part of the lecture, which is the last session of the lecture, is basically taking NLP data and building machine learning models on them. So as we have already discussed, NLP, I've been saying that since the start of this lecture, is that NLP is basically nothing but a feature engineering exercise, right? So we basically have a lot of text data. We cannot feed that as it is to NumPy. So we have to figure out a way where we can convert this text data into some sort of numeric representation, right? And that's exactly what we are going to do to kind of do the machine learning, supervised machine learning part, right? So again, just to be clear, so what we are doing is basically the supervised machine learning part of the approaches I just talked about. And in supervised machine learning, basically examples I've already told you, sentiment detection, detecting which author has written which article, detecting whether some article, basically some text contains a foul language or not. Different applications could be there, but the idea behind all of them is the same, that you have got a text and you're going to classify it whether it has got its positive or negative sentiment, it is from this author, this author, or this author. So classification tasks that can basically be there, right? So you have got text and you've got to classify that text into particular buckets. So now when we are thinking about something like that, obviously the only thing now we have already talked about pre-processing, cleaning steps. Now the only thing that is remaining is once you have the clean text data, right, after you have done lemmatization, you have basically reduced everything into very nice clean text. All that is remaining right now after this is basically taking this text and somehow representing it numerically, right? And that's exactly what we are going to learn right now, and that's probably this approach that we are going to talk about is called bag of words approach, and that's, I would say, almost 99% of all NLP related, supervised NLP related tasks that are there out there, all of them kind of use bag of words almost, right? So pretty interesting thing, and let's just figure out. So not very rocket science kind of a concept, again very simple concepts out here. So what is bag of words? Bag of words is basically you have this text, say, right? So your text goes like this is NLP. Right, so this is NLP lecture. I don't know, just my handwriting probably might not be the best. I wanted to write awesome, yeah, that's what it is. So this is NLP lecture and NLP is awesome. That's what I kind of wanted to write. So the thing to kind of note about this is that, so this is a text, right? So what we want is basically from here we want something like a numeric representation, right? So something like which basically has a lot of so this basically is one particular data point, and this is basically one row. So this is my row number 1, and I want to kind of represent using some numbers, right? So it could be 1, it could be 2, it could be 5, some numbers, right? 0.3, 0.2. So that's the idea. That's what we want to kind of do out here, is basically take this text data and represent it using some kind of a numerical form, right? That's what NLP feature engineering is all about, right? Feature engineering is basically we have this text, we do not know, we cannot use this as a direct feature, right? We cannot use this text as an input, right? This cannot be my X. This is my X and there's a Y corresponding to it, right? Which is say basically there's a positive sentiment with it. So this is my X and this is my Y. Y is positive, and what I need to do is basically convert this X into some sort of numeric form like this. So this is my entire X is my X, and then I would have Y, which is basically like 1 and then 0, and then this is just for some another text I will have something, some representation like this, and then 0 for that. So that's the idea, right? So all we need to do is basically, if we can reach here, right, where we have represented this text in some form of features, we have basically extracted some features and we have represented that text using this kind of features, then we can basically do machine learning, right, the way we know all as it is. So all we need to figure out is basically how we can take this text and basically represent it using some kind of feature representation like this. Now obviously there are a lot of, as I said, bag of words is one of the most prominent one used. Obviously apart from bag of words, something which are more primitive is basically checking if say positive words are there or not, right? So you would basically have all the positive words that you can think of, say awesome, happy, best, and all of this. So basically we'll have something which is basically a feature which would say awesome. Okay, probably this is awesome, best. So you will have all the words and then you will basically see 1 or 0, right? And then something like this. So this is one way of representing. Now that's the most primitive way. So what we now want to do is basically something very similar to this, where we basically do is take all the possible words that are there in that entire series, right? So this is first text, then there would be some other text, right? So there would be, so if you look at all the text that is there in your entire training data, right, I'm not talking about one particular data point, but in your entire training data, say you come across, say there are 1,000 unique words, right? So this was one way, the one that I've crossed out. The slightly better way, which is basically the bag of words model, which is basically, if you look at your entire training data, you say there are 1,000 unique words that you can see. So what you will do is basically now you'll have a feature which says word 1, word 2, word 1,000. So you basically have now a feature which basically says if word 1 was present, if word 2 was present, or probably even better, why have just present? You can just present number of times word 1 occurred, right? So word 1 occurred in this particular text, say word 2 is NLP, right? So this is say NLP. In this particular case, word 2 has occurred 2 times in the first text, right? So the first word is say is. So is has occurred 2 times. So 2 times is has occurred, NLP has occurred 2 times. Say word 3 is awesome. Whatever. So word 3 has just occurred once, right? So that's the idea. So every time, so what you have done is you looked at the entire training data. You have looked at number of unique words. Those words you have put in a group or in a bag. You now get the idea why it is called bag of words, right? So you basically look at the entire training data, you see number of unique cases, unique words that are there, you put them in a bag, that's now your bag of words. Now you basically, your features are nothing but if that word was present and how many times, right? So you will basically the frequency of that word in every text document. So that's how you extracted feature out of this. Very simple, very intuitive concept, right? There's nothing very complicated about this thing. So this is as simple as this. You're just kind of trying to look out what words are occurring in the sentiment. So if there says a lot of times, how will basically you are trying, the idea behind using something like this is basically say you're trying to do sentiment analysis, and you know that if words awesome, best, and all of these are something that are occurring in the sentence, then probably it's a positive sentiment. Now one way, as I have already explained, is basically first have a list of all positive words and then see if they were present or not. Now you would not know what are all the positive words that are there out in there, right? Or what are the positive words people could use. So instead of trying to make a list by yourself, what you have just done is you take the entire training corpus, right? Corpus is that entire data that you have across all training examples, right? Each training example is say one review. So you take all those reviews, you look at the total number of unique words, and then for each review you basically say how many times each of those words in that bag occurred. And that's the first approach that we call count vectorization. And so that this is this concept as a whole, where you kind of take this bag of words approach, where you take a text and you vectorize it into a numerical representation. This is called the vectorization process. So vectorization process, you have a text, you take that and represent that using, so this whole process, that you have a text and you represent that using a numeric representation, right? So that is called vectorization. So now vectorization can happen in multiple ways. Bag of words is one way, and bag of words also comes in multiple variants. We are just going to see some of them. So now let's look at this example. So what we have discussed as of now is something called count vectorization, and we are going to focus on that as of now mostly. But let's now see this particular example. So now you have basically say these are how many examples. So that's the first one is, say the first line is one example, second line is another example, third, fourth, right? So there are 4 examples in there, and now let's see what are the kind of common unique words across them, right? So if you look at the common unique word, there are some 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 unique words that are there in the entire corpus, right? So each of your line is one training example. See, this is not the case probably in this particular case, but let's assume that this is your first example, the second is the second example, the third line is a third example, third training point, and the fourth is the fourth line is a fourth training point. Now if you look at the entire 4 lines, you see that there are 10 unique words. So now when you are representing the first word in the sentence, right, the first line in the example, so you would basically represent it as something like it, 1, 1, 1, 1, best. So basically every word that had occurred here, and what is the count of that word, you're basically putting a 1 to that, and 0 if that word has not occurred, right? So very simple. So now you have 10 vector 10 feature representation of this particular text, right? So this particular text, the first line had just probably 1, 2, 3, 4, 5, 6 words, right? And you have somehow converted those 6 words text into a 10 vector representation. The 10 vector representation looks like this, each word and its count, and if 0 if it was not there, right? So this is exactly the vector I'm talking about. So it basically is 1, 1, 1, there are 6 ones and then 4 zeros, right? For the frequency for the rest of the lines look like something like this, 1, 1, 1, then 0, 1, 1, 1, 0, right? So basically each word, whether it occurred or not, and if it occurred, the count of it, right? So that's all you have got. So now, this is awesome. This is exactly the concept behind count vectorization models, and this is something that you, as I said, count vectorization is something that is, again, most of the times you would be using bag of words approaches when you are doing NLP supervised tasks, and out of those cases you would again be using count vectorization probably for most of your use cases. Now count vectorization has a slight problem, in the current way we have discussed, which is that, say you are trying to do negation detection, right? So in case you are saying it's not good, right? So that's a negative sentiment, it's not good. So that now to kind of explain that, I'll probably write that out for you. So this is it's not good, right? So this is the text that you have. Now you basically want to represent this. So say there are another 15, 16 odd sentences, and out of that you say have 10 unique words, right? So you have x1, x2, dot, 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 x10. So those are your 10 unique. For some reason I'm not able to draw the 0. Yeah, I'm somehow able to do this. So x1, this is 2, okay? This is x2 and x10, right? So these are your 10 features, and say your first 3 words are it's not good. So there are 10 unique words, and now you're going to represent this as, the first is 1, the second is 1, 1. This is for it's, this is for not, this is for, okay, I'm not able to type somehow. Yeah, this is a problem here. It's not good. So these are the three words. So this first is basically if the word its was there and its count. The second feature is not and its count. The third feature is good and its count, right? So that's the idea when you're doing count vectorization. So you basically represent them as 1, 1, 1 and then you have 0, 0, 0 all the way, right? So now what is problem with this is basically it's a negative sentiment, but you can see that for the corresponding feature good, you have a corresponding representation which says 1. Right, so probably the algorithm might get confused that if there's a word good associated with it, there's supposed to be a positive sentiment that is supposed to be associated with it, right? So how do you kind of capture this thing, right? It's not good is basically a two word. There are two words out here which basically together probably says that it's a negative sentence. If you look at individually each of them, not probably doesn't say anything, right? It just probably it could have the word could have been not could have appeared earlier in the sentence and then it would not have basically had any impact on this positive sentiment, right? So because not just appears before the word good, together if you look at them they are a negative sentiment. If that word not had occurred earlier or anywhere else in the sentence, you probably, if there's a word good in it, you would probably tend to say it's a positive sentiment. Now, because these words are occurring together and then not and good probably makes a suggestion that probably it's a negative sentiment, right? So, how do you capture this whole thing, right? So, the simple idea is that instead of basically having features just for each of the single words, you're going to now have features. So, you're going to have this 10 features as it is. So, this is your 10 features x 2 and after that you're gonna have your 11th feature, your 12th feature and your 13th and so on, where each 11th word is basically the 11th feature is basically if the word if the word not good was present or not, right? So there are now, instead of looking at just individually what are the unique words are there, now you're also looking at all the possible two word combinations that could be there, right? And the reason behind that, as I've already explained, is basically to capture this kind of context, right? So this is something called negation detection, where there is a word which is negative word and because it's associated with a positive word, combined they kind of imply a negative sentiment. So this is the thing, to capture those kind of examples, those kind of tricky situations, what you have done is basically you have now, instead of capturing a feature for each of those particular, now these x1 to x10 are basically all the features for your individual words are present and their count. And if from word feature number 11, basically what you have done is you are capturing whether this group of word is present or not in that particular sentence, right? So now you're going to just look at all possible two word combinations. So it's not good, it's not, so those are two kind of combinations. So now you look at some other sentence, say happy new year, right? So then you basically gonna look at happy new year as one feature, then happy new year as one feature. You're gonna basically look out at all possible two word combinations that could be there which are occurring successively, right? So you're gonna have a feature for it's not, you're gonna have a feature for not good, you're gonna have a feature for happy new, you're gonna have a feature for new year, you're gonna have all sorts of two letter combinations that could be there in your entire training document, right? So though it kind of, I know what is the back of your mind, you're probably thinking this is really bad, right? You're kind of doing extremely high computationally expensive processes just to capture a small thing, which is absolutely correct, which is basically a major concern with kind of doing these things, and we'll come to that in a while later. Probably next lecture you will probably kind of get an idea of how do we tackle all of this, but definitely your concern is correctly placed that this is a computationally expensive process where you're going to take all possible two word combinations. But for now, let's assume that you do that. So what is this particular thing, that two word combination that you looked at? So that is called a bigram, right? Bigram is basically all two consecutive words that can occur, right? So those are called bigram features when you're looking at two word combinations. Obviously now if you can go a slightly more computationally expensive process where you look at all possible 3-letter words that are there, right? All possible 3 combinations of words. So that is called a trigram and so on. So when we first talked about the whole idea where we look at each individual word if it was present or not and its frequency, that was monogram. When you look at two possible two word combinations, that is bigram. When you look at 3 possible combinations, that is trigram. Trigrams obviously expensive, you don't want to go anything more than trigram for sure. So that's the idea. So now as you can see in the bigrams in the first line of the text of the previous section, if you remember previous section, the text was this, right? It was the best of times, right? That was a line, and from that you can basically have this other number of bigrams that you can have from that. Now you look at your entire training corpus, you would probably have probably another 10-15 bigrams. So you already had 10 features earlier. Now on top of those 10 features you have another 15 features which are your bigram features, right? So the first 10 were monogram features, the next 15 were bigram features. You could have another features which are trigram or something, but that's the idea. That is what we are. That is a slight improvement on your monogram model, because monogram model might be biased or might not be as effective, let's say, when it comes to negation detection.
Log on to GreyAtom's learning platform to unlock more free content. Subscribe to our channel and hit the bell icon for regular updates.